Hey, it's hard enough as it is without it. So Okay, here you go. Notes 3, limits numeric and analytically. Hashtag be happy. Life is too short. We're only here for a short while. Might as well just be happy, guys. So try not to stress too much. Don't take life too serious, including my class as well. Just try to learn. Don't make it about like, oh, I want to get that A. I want to get that A. Because a lot of times you guys want the A, but what does it mean? So just focus on learning. If you focus on learning, that will take care of the A. I real quick. I know you guys have heard of this before, but I'll tell you guys real fast. Don't hate me, guys. I think it's really sad. It happens. Go talk to a professor, and you'll see. I think it's really sad when there's students at the university that are coming out with 4.0 GPAs, but they can't pass their boards to practice law, to practice medicine, to practice pharmacy, whatever it is. You went to pharmacy school for all those years, 7, 8 years. You have your doctorate of pharmacy, and now you're about to become a big-time pharmacist with a salary of 150K or more, but you can't pass your boards. And if you can't pass your boards, guess what? You can't practice pharmacy in the States. You don't think that's sad? And it happens. If you think I'm joking, go to, I don't know, the R Edit ones, or you Google like people with 4.0s that can't pass boards. So what that tells me is that they're robots. They just memorize stuff just for the test, and then they dump it. Don't do that. Math builds upon itself. I'm sure medicine is the same way. I'm sure to become a surgeon or whatever, it builds on itself. So make sure that you're really learning how everything reacts to itself, how everything builds on itself. And then you don't have to ever worry, right? Because you learned it genuinely. So you don't have to worry. The grade will come afterwards. Okay. Are we cool? Sorry about that little speech. I just felt the need to say that. Sometimes I want a church where I just say random things, whatever comes into my brain, and then have a soundboard like you guys told me to, or whatever, and then have like push like new and techno. I'm gonna try to get a soundboard, a cheap one, like $100 or whatever, and I'm just gonna record random sounds, and I'm gonna push them when you know.
God, you can just get an app for that. Why are you using money?
Because I want to be fancy.
Okay, well you should do it like you should say.
Start. Okay, you're right. I'm a teacher. I am poor.
No, that's not what I'm saying. I'm saying you get an app and then you save up money for the big dog soundboard.
Okay, I'll try it out with an app first.
You should just buy the DJ, the whole DJ set while you're at it.
No. All right. Let's focus. I know some of you guys are really good at like pushing the teacher to like stay off topic for a long time. I know you guys are professionals. It won't work with me because it works a little bit, but it won't work fully because I got to keep going. All right, here we go. So here we go, guys. Limits 3. We're finally going over some of the more those subtopics that you've been seeing on your UH quizzes. So a lot of this, I already put it in here. So I had time during the summer, and I was able to make these notes kind of pretty. So I put a box and everything. So you can see everything that's from notes 2. And then these right here are new to you. What kind of new? Some of you have been asking me questions, and you guys already figured it out. Here we go. Let's go ahead and start. So this is coming from your textbook. If you guys read it real quick, does that make sense to you? No? Okay. It's okay. I think these authors sometimes think that you guys are math majors. All this text means is try direct substitution. That's all it means. Theorem 2 just means try out direct substitution first. That should be your first go-to. So to try direct substitution. If you get something that's undefined, we must try something else. Okay, so let me be real with you. If you get an indeterminate form of 0 over 0, there's a chance that it probably has a limit. If you get a number over 0, that x value that it gives you 0 is probably a vertical asymptote. Does that make sense, guys? Chav, I don't know what you're talking about. Okay, let's go right into it. Example 1. It says limit as x approaches 3 of x squared times 2 minus x. If you wanted to, you could graph this and see what the y value is when x is 3. You could do that. But what should I try first? Direct substitution. There is no fraction, so you're definitely going to get an answer. You just go 3 squared parentheses 2 minus 3. Notice that I no longer write the word limit in the front because now I'm just putting direct substitution. All this is just numbers. There's no variables. So there it is. And then I just go, okay, that is 9 times negative 1. So this is just negative 9. If you want to write it again, limit as x approaches 3 of x squared parentheses 2 minus x That is negative 9. If you want to do that, that's fine. You don't have to, though. And that's it. Does that make sense, guys? All right, next one. What am I going to try first? Direct substitution. As long as you don't get a 0 in the denominator. Do I get a 0 in the denominator? No, so we can just do direct substitution. 2 squared plus 2 times 2 plus 4 over 2 plus 2. All right, we're just going to add them up. Let's see. 2 squared is 4. 2 times 2 is 4 plus 4 all over 4. So that looks like, well, look, I have 3 of them, so 3. You could also add them up. 4, 8, 12. 12 divided by 4 is 3. How do we feel? Yeah, that's it. So always try direct substitution. All right, let's see what we got next. It says, all right, cool. I think those are straightforward. What if we had a function like this? So there it is. And I asked for you to find the limit as x approaches 0. Can we still try direct substitution? Why or why not? Yeah. Can you close the door, Samantha Lopez? Sorry, miss. Can I try direct substitution with this limit? No, because I get a 0 in the denominator. Now, observe that you also get a 0 in the numerator, 0 over 0. So that's what I was talking about. If you get 0 over 0, like this, I'm going to write, you probably have a limit. You probably have a limit. And then if you get a number over 0, the limit does not exist because that wherever that x value gives you a 0, that's a vertical asymptote. So you can also say the behavior, infinity, positive infinity, negative infinity. So that's what we're talking about. And relax. Here's how we're going to combat it. We're going to use our calculator. Well, I don't think I have access to my calculator just yet. I'm going to use Desmos. Oh, you know what? You guys were having issues with piecewise functions last time, right? We figured out, I think I was talking to someone and we figured out how to do it with Desmos really fast. So don't worry, I'm going to delete all this and then I'll get back to it. So if you wanted to, I'm just doing this really fast. F of x equals x plus 3. And you wanted to do this piecewise. Did I put a comma? Did I put a semicolon? I don't remember. Oh, curly brackets. Curly brackets, x less than 2. And then look, it graphs x plus 3 for x less than 2. So now you no longer have to have issues about piecewise functions. You can use Desmos and use the curly brackets and then just tell it the restriction. So it graphs x plus 3 as long as x is less than 2. Cool, right? Okay, so now let's go back to our problem. So here we go. I'm going to go f of x equals, and I'm just going to type in the expression, which was x divided by, what did I have in the bottom? Square root x plus 1, and then outside the square root was it a minus 1? Minus 1. So there it is. And notice if I go, I wanted 0, right? And it looks like, just looking at it, it looks like it's 2. But look, if I push f of 0, you get undefined. But you can see what's happening. So I'm going to write table, and I'm going to write, for the purposes of this, because the way I have it, I have a little table there. And I'm just going to put the values, and well, here where it says y, I'm going to write f of x. I'm just going to put the values that I have right here. Negative 0.2, negative 0.1, negative 0.01, negative 0.01. So what's happening here? I'm getting closer and closer. Let's approach 0 from the left, getting closer and closer. So I'm approaching 0 from what direction? From the left. So I can't see this and the other one at the same time. So you guys tell me the values. So what's the first value? Negative 0.2. So there it is. It's that value there. Type in 1.8944272. The more digits you can type in, the better. What's the next one? Negative 0.1. So 1.948633. What's the next one? 0.01. There it is. 1.99498. And there's the last one, negative 0.001. Yeah. Negative 1.999499999. What is happening? What is happening? I'm sorry. I remember using short. Yeah, the y value is getting closer and closer to 2. So make sure to put those values in there in the table. And I'm just going to write right here, I'm just going to write limit as x approaches 0 from the left of this function, f of x, is getting closer and closer to 2. How do we feel? Not bad, right? All right, so here we go. I'm going to go back, and I'm just going to delete these values. Okay. Someone said no. Yeah, I'll wait. I'm waiting. Cheers. Oh, look, Alani. I'm drinking an Alani. Are these? Is this your favorite drink?
I actually hate Alani.
Oh, okay. Why do you hate Alani's when your name's Alani?
I don't know. I think that they're gross.
Oh, it tastes okay. Huh? Miss, I didn't choose. I just took it out of the refrigerator from the teacher's lounge. You think I would have chosen the little baby one? I would have chosen a big one.
You're right.
All right. All right, professional distractors. Here we go. So I am deleting those values, and now I'm going to approach 0 from the right. What was my first value there? 0.2. So there it is. I'm going to push enter. Then the next one I'm assuming is 0.1. So there it is. And the next one is 0.01. 0.01. There it is. And then the next one is 0.001. I'm sure this is the last one, right? And now notice, again, the same issue. Those y values are getting closer and closer to 2. How are we feeling? Yeah, put as many digits as you can. And I'm just going to write, don't worry, I'll come back if just in case. Limit as x approaches 0 from the right of this function equals 2. All right, and I know, you can see the graph, and looking at the graph, it looks like I was continuous at 0, but you're not continuous. You actually have a hole at x equals 0, but it's approaching that y value of 2. All right, so I think we're good, guys. So now look what we're going to say here. So from this, we can conclude that the limit as x approaches 0 of x over square root of x plus 1 minus 1 is equal to 2. And there it is. Our first limit using tables. What's up?
Will this question ever be asked in the no calculator section?
Mm-hmm. But differently. We're rookies right now, so we have to present it like this. Don't worry, we'll get better. What's up?
So, do we have decimals on the test?
Only for the calculator section. There is a no calculator section. 60% of the exam is with no calculator. So that will probably be no calculator. Well, you guys are getting ahead of me. That's what she wants to know. You would do it with algebra. All right, guys. Let's go ahead and go right into it because you guys are asking. This is all by design. If you had this question and you had no calculator, how would you do it? You would do it like this. You would go, I'm going to go limit as x approaches 0 of x over square root of x plus 1 and with a minus 1. And I'm going to put a bracket on all this because it is my argument of that limit. And what is making this hard, quote unquote? The numerator or the denominator? So I'm going to multiply by the conjugate of the denominator. So square root of x plus 1 over square root of x plus 1 plus 1. Close it. Chop. Why? Because this gives us a situation where this looks like the difference of squares. And the difference of squares is going to cancel out that middle term. Chop, I have no idea what you're talking about. I see y'all's faces. So when we do a plus b times a minus b, that's the difference of squares, right? Look, a times a squared. A times b minus ab, b times a plus ab, b times negative b minus b squared. Look what happens. This in the middle cancels out, and you just have a squared minus b squared. That's what I want, something that does something like that. So when I multiply by the conjugate, I don't have to worry about these middle terms. So, Chop, so what are you saying? Here's what I'm saying. Look at this. Limit as x approaches 0. In the numerator, leave it like this. X, parenthesis, square root of x plus 1. But in the denominator, write it like this. This is like your a, and this is like your b. So I can just go right into that. So square root of x plus 1 times square root of x plus 1, that's just x plus 1. Negative 1 times the positive 1, minus 1. These cancel out. So now, limit as x approaches 0 of x, parentheses, square root of x plus 1 all over x. And I'll slow down. I have a product in the numerator, and then I have a quotient divided by x. Multiplying and dividing are inverse operations. So what can I cancel? X's. Now that I've canceled those x's, now can I do direct substitution? Yes. What is 0 plus 1? 1. What's the square root of 1? And what's 1 plus 1? I get a 2. Oh, isn't that what my limit was? Yeah. So there it is. Without a calculator, that's how you could have done it. You guys are about 2 steps ahead of me because we were going to do that eventually, but you guys wanted it. So here we go. We're good. We're good, miss.
Okay. I don't know why we're doing this.
Okay. Example 2. Another one numerically. You guys ready? So I'm going to go. Obviously, we're cheating because we have a graphing calculator here with Desmos and you can already see what's happening. But let's do it. Okay, let's not look at it. Let's see if we can just do it here. So I'm going to replace sine x right here. Or you know what? Well, that's fine. Sine x over x. And yeah, let's start from scratch. All right, here we go. I'm gonna approach 0 from the left. So what's my first input? Negative 0.2. So type in 0.9933. Next one, I'm gonna put in negative 0.1. Type 0.9983. Next, I'm gonna type negative 0.01. Type 0.9999. Actually put the 8 afterwards, so put 5 digits after. So for the negative 0.2, put 0.99334, and then for the negative 0.1, put 0.99833. For the negative 0.01, put 0.99998. We're still okay? Look at this last one, negative 0.001. 0.99999. What is it getting closer to? 1. And not to cheat, but here is the graph. Look at that graph. There is a hole at x equals 0, but you can't tell with this one, but there is a hole. There's a hole because they're not defined. See, f of 0 is undefined. All right, so there it is. So make sure to put those numbers in there. So limit as x approaches 0 from the left of this function. Actually, it doesn't say f of x, so I'm just going to write sine x over x. Sine x over x is equal to 1. Now let's try it from the right. Obviously, you already saw the graph, so it's going to be the same. But let's try it out. Let's not cheap out. So delete, 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 delete. Okay, here we go. What's my first value that I put in? 0.2. So type in that. I'm approaching 0 from the right. So the next one, I'm going to put 0.1. It should be the same y values, guys, because it's symmetric on the y-axis. It's an even function. The next one, I'm going to put 0.01 and 0.001. They should all be the same digits because it's even. It's an even function. So it should be the same. If you want to be fast, just copy the ones that you have on the top. What is it approaching again? 1. So on the side here, you're going to write limit as x approaches 0 from the right of sine x over x is equal to 1. All right. So from this, we can conclude what? Limit as x approaches 0 of sine x over x is equal to 1. And then it says you can also verify this by graphing, which we just did. Don't be tricked by the calculator. There is, in fact, a hole at x equals 0. Okay. Let me see if I can trick you really quick. Well, I'm not trying. Well, I already gave it away. What's this limit? Limit as x approaches positive infinity of sine x over x. Is that also 1? What do you think? It's a safe space. Yeah, well, yeah, you're right. It's not. Guys, can you give me this limit? Just thinking about it, just analyzing it. Yeah, I think you can. Sine x is just going between what and what number? You guys all have pre-calc. Sine x is just going between what 2 y values? No, not 0 and 1, but negative 1 and 1. It's never bigger than 1. It's never smaller than negative 1. In math, the further left you go is smaller. I know that's not the case in physics, but in math, negative 10 is smaller than negative 1. In physics, it's not right. Because you're talking about magnitude. All right. So think about it, guys. Look what's happening in the bottom. The top, the numerator is just going between negative 1 and 1. The denominator, x is approaching infinity. So you have some number between negative 1 and 1 divided by something huge. This output is going to keep getting closer and closer to 0. Some number divided by something huge is going to be approaching 0. Chop, I don't know what you're talking about. Look at this. 1 divided by 1, that's a 1. 1 divided by 10, that's a 0.1. 1 divided by 100, that's a 0.01. 1 divided by 1,000, that's a 0.001. See what happens as the denominator gets larger and larger? You converge on the value 0. I always got to be careful with saying it's getting smaller and smaller. It is technically getting smaller, but you're converging at 0. In math, getting smaller means you're going more negative or you're decreasing left to right. Are we okay? Okay, so what formulas do you have to memorize? I mean, you don't have to, but it makes life a lot easier. Memorize these formulas. Here they are. And 1 and 2 really are the two most important ones. Number 3, you see a lot with statistics and interest formulas and all that. Okay, really quick, I'm going to write a variation of it. It says careful with variations, use special limits. So it doesn't have to just be sine x over x. The arguments have to match. So it could be this, limit as x approaches 0. Do you guys like happy faces? Sine of happy face x over happy face x equals 1. Oh, I can see some happy face haters. Okay, let's use triangles. Limit as x approaches 0 of sine triangle x over triangle x, that equals 1. It could also be the reciprocal, because the reciprocal of 1 is 1, right? So you could also look like limit as x approaches 0 of sine, actually, let me put I said reciprocal, so let me put happy face x over sine happy face x. That is also equal to 1. Does that make sense? Galan? Tell me. Okay. This also equals 1, guys. It does not matter. Chop, why does it not matter? Because if I go to Desmos, well, really because the reciprocal of 1 is 1. That's the only one that you can do that with. But if I were to go to Desmos really fast, look, I already have Desmos here. You see this graph? That's that sine x over x. Look what happens if I switch it and put g of x equals x over sine x. OMG, it's that green one. But look, is it still converging at 1 as x approaches 0? Yeah. So there it is, guys. I hope that you're entertained with all this math here. Okay, what about this one here? So I'll color code it. If you have a different color pencil or pencil and pen, maybe this one. So I'm doing that one now. It does not matter. Limit as x approaches 0, 1 minus cosine of happy face x, and really it doesn't matter on this one either. You can have a sad face x, and it won't matter. Chop, it won't matter. Are you sure? Like, yes, I'm sure. We'll try it out right now. Limit as x approaches 0. It could also be cosine happy face x minus 1 over frown x, and it'll still be 0 as well. The reciprocal is not true, but you can change the polarity of it, and it will be true. So yeah, let's try it out. Let's see. And don't worry, guys. I'm gonna come back to this, so you can. And plus, I'm recording, so you can always come back. So here it is, and I'm gonna write. Let's try f of x equals fraction 1 minus cosine x. Let's just try the traditional one over x. Notice what happened. There's a hole. If I were to type f of 0. Notice that I get undefined. So there's a hole at x equals 0. Do you guys see that? Now look what happens if I start putting coefficients in the front of this. Actually, let's start putting coefficients in the front of this first. 4. Oh look, it doesn't matter. It's still 0. Put a 2 down here. Oh look, or 3 down there. Oh look, it doesn't matter. It's still 0. So do you see how it doesn't matter? This one does matter, I think. Let's see. Let's put a 5. Yeah, so the coefficient in front of the cosine does matter, but the one in front of the argument does not. So that could be a 4, that could be a 3, that could be a 7, that could be a 2. I hope I did it right. Yeah, I did. I didn't. Did I say anything? I'll look at my recording, but I hope I didn't say anything about putting in front of the cosine. I did it right. Okay, good. But I don't want to say wrong stuff. But see, that's a happy face. That's a sad face. Put that in your notes. That means it could be different numbers. So sad face, happy face. You can have different numbers in front of it. That's a happy face, that's a sad face. That's a happy face, that's a sad face. You can have different numbers in front of them, and it will still equal 0. Are we okay? All right, I think we're good. Let's see, there are several limits that are special for this course. This will suffice. All right, so that we're talking about these special limits. When we can't do direct substitution, must we always resort to tables? No, we can do algebra. Let's see if we can do the next example with the property we just learned. Okay, so here it is. This, I guess, technically is considered a special limit, I guess. Put the word special. So we don't know what this limit is, but we know, what do we know right now? We know limit. Since this is an x, we're just going to say limit as x approaches 0, because that's what this is approaching, of sine x over x is equal to 0. That's all we know right now. So from pre-cal, we know that tan x is equal to what over what? So that's what I'm going to expand. I'm going to go limit as x approaches 0, bracket, and I'm going to write tan as sine x over cosine x all over x. Are we still okay? Okay, here we go. I'm going to do keep, change, flip. So that means I'm just going to move that x right next to that cosine. Limit as x approaches 0, bracket again, sine x over x cosine x. Close it. That's my argument right there for that.
X approaching like on the one up there in the corner. Like isn't it one? Like is it 0 because it's approaching?
Yeah. I'm gonna erase that from my video so it doesn't look like I made that mistake. Thank you, Miss Henderson. I'll probably write it, I'll probably leave it in my video. I'll just put like a little like, oh, mistake coming or something. Yeah, you gotta tell me these things. I'm not fully awake yet. I haven't drank my whole alani yet. All right, so here we go. I'm gonna expand this. I hope when I look at my video, I hope I at least said 1 and I just wrote a 0 there. So here we go. Limit as x approaches 0, bracket, and I'm gonna group these together like that. So I'm gonna write sine x over x. Child, why are you doing that? Because that's what I know. We know that the limit as x approaches 0 for sine x over x is 1. Does that make sense to you guys? Times 1 over cosine x. There it is. That is still the same. That's still the same. If I multiply these in the denominator, I'll get an x cosine x. If I multiply sine x times 1, I'll still get my sine x. Are we still okay, guys? All right, here we go. The moment of truth. What is the limit as x approaches 0 of sine x over x? 1 times, now I can do direct substitution. Here comes pre-cal, and it's not extreme pre-cal. I can do direct substitution with the 1 over cosine x. What is cosine of 0? 1. So this is like 1 times 1 over 1 to keep it consistent. What's 1 times 1? So there it is. So from now on, so maybe you want to write this down in under your special limits up here. Put number 4 and put limit as x approaches 0 of tan x over x is equal to 1. And you can also do a special case. So limit as x approaches 0, and I'm going to write it as happy face x over tan happy face x equals 1. And that's part of your fourth one here. It's also the same, tan happy face x over happy face x also equals 1. You guys like happy faces? Are we doing okay so far, guys? Yeah. I got you, miss. Let the record show that I got them. All right, let's see. Example 5. There are times where we resort to algebraic manipulation. Relax. Some of you already have experience if you've been asking me. First things first. That's a song. First things first. I'm the realist. I do well. And that just reminded me of that as soon as I said it. All right, first, can I do direct substitution? No, because you get a 0 in the denominator. Notice that if I do direct substitution, I get 0 over 0. It's indeterminate form, so it probably has a limit. All right, what are we going to do next? Well, the numerator is the difference of squares. We talked a lot about it last year. So that's going to be x plus 1, x minus 1, all over x minus 1. If you want to put a bracket over all that, you can. Just for whatever reason, I just didn't put 1 there. Again, now I have factors, x plus 1, x minus 1. I have another factor in the denominator, x minus 1. What's going to cancel? The x minus 1. Multiplying and dividing are inverse operations. I can just cancel those. Now can I do direct substitution? What is 1 plus 1? So that answer is 2. I know some of you were doing this for the UH quiz through graphing, but look, you don't have to. You can do that like that. Are we okay so far? All right, let's go to example 6. The letter A is pretty much the same one as the one we just did. I can't do direct substitution because I get a 0 on the bottom, but I can expand it. I can rewrite it, limit as x approaches 1. The numerator is still x minus 1. The denominator is the difference of squares, x plus 1 times x minus 1. What's going to cancel? X minus 1s. Now can I do direct substitution? I can. What is that limit now? 1/2. Make sure the 2's in the bottom. Are we okay? Look at letter B. Can I do direct substitution? No, because you get a 0 again in the denominator. But you again look and notice the observation, 0 over 0. It probably has a limit. Limit. I haven't evaluated it yet, so you got to make sure to put the word limit. As x approaches 0, what can I factor out in the numerator? An x squared, and you're going to have 3x plus 20. Are we still okay? What can I factor out in the denominator? X squared. So you're going to have, you can also factor out a 5, but let's just factor out the x squared. You're going to have 5x squared minus 10. Are we still okay? All right, let's see. What's going to cancel out? And now, can I do direct substitution? You can. So you're going to get 20 over negative 10, because you're going to get 3 times 0, which is 0, so 0 plus 20. And then on the bottom, you're going to get 0 again, minus 10. So 20 divided by negative 10 is negative 2. Do you see how we're doing it, guys? Hit me.
How did you get 1/2?
Oh, I just did direct substitution. No, please ask. See that one? What's 1 plus 1?
2.
But it's in the bottom, so I keep it in the bottom.
Oh, okay.
You know what I mean? Yeah. No, ask, miss, ask. Okay. Here we go. Letter C. I bet you're wondering why there's so much white space. Or maybe you're not wondering. We're going to have to do algebra. If you can't do, okay, first we can't do direct substitution because we get a 0 in the denominator, right? So here we go. Let's do some algebra, guys. You did this exact question in pre-cal. You just didn't have the word limit in there. Do you remember that question? No? Oh, okay. Dang, that sucks. All right, here we go. I'm going to multiply the right one by 2 plus x over 2 plus x, the right term in the numerator. I'm going to multiply the left term in the numerator by 2 over 2. So here's what I have. Limit as x approaches 0 of 2 over 2 parentheses 2 plus x, close it, minus 2 plus x over 2 parentheses 2 plus x, close it, all this over x. Let me know if we are okay. Estamos bien. Oh, that's all I can say. I don't know any other language. Some of you went to Greece this summer. How do I say? What do they speak over there? Oh, okay. How do I say that in Greek? No one knows. Why aren't you guys trilingual? Oh, stop. Guys, it's a joke. LOL. All right, here we go. Sorry, guys. I know some of you are not entertained. Here we go. You see that minus? Distribute it. So here we go. Limit as x approaches 0, 2 minus x over, and I'm going to do keep, change, flip. So I'm going to write 2 parentheses 2 plus x, close it, and I'm going to bring that x up. Did I confuse anyone with that? All I did was keep, change, flip. This is one big fraction, and then this is like x over 1, so I go times 1 over x. It's going to bring it to the denominator, so I just brought it up. Okay. Yeah, I'm just going to do the keep, change, flip over here on the side. Look, guys, if I have a over b, and I'm dividing this by c, so the fraction is like a over b, right? So that c is like c over 1. I can change this to a over b times 1 over c, and now look where that c ends up. That c ends up right next to that b. LOL. Do you guys see that, guys, or no? So this fraction here, so look, When I distributed that negative, boom, boom. 2 minus x over the denominator, 2 plus x, and I just moved that x next to whatever that common denominator was. There it is. Does that make sense? Milan? Did you not like this? Wow. All right, let me do the... Look, I'm going to erase this, but I'm going to write it in here for you guys. 2 minus x over 2 parentheses 2 plus x, close it all over x. That's how it should have looked. That x was like x over 1. So I'm going to erase this in a little bit. I'm just doing it for now, guys. 2 minus x over 2 parentheses 2 plus x, keep change flip, times 1 over x. Oh, look, it ends up here in the bottom. 2 minus x over 2 parentheses 2 plus x, close it with an x. Yeah? Okay. Yeah, look, it's the same thing as this, but I think this looks cleaner than all that. Tough crowd. All right. You doing okay, Pearson? Here we go. You already got the answer? Oh, I thought you had already solved it. All right, here we go, guys. Let's continue. What is this is gonna zero out? You see these right here? Bam, out. And now that I've zeroed out the 2's, I have a negative x in the numerator and I have an x in the denominator. What can I do with those? Bam! You have a negative 1 in the numerator. Don't forget that. Now can I do direct substitution? Yes, negative 1 in the numerator. 2 plus 0 is 0. What's 2 times 2? There it is. How are we feeling? Are we feeling all right, guys?
Where did the 1 come
From right here. That's a negative x. And I just canceled the x, but it's still minus 1. You know what I mean? Yeah, hit me, guys. Hit me. All right, here we go. Oh, look, we got our first trig. And don't worry, this is why I didn't give you any delta math with trig, because I know we're going to have issues with this. I see it coming. We'll see. That says sine 2x over x. The only trig properties you know right now, and let's make sure that I don't make a mistake. Limit as x approaches 0 of sine happy face x over happy face x equals 1. Are we okay so far? All right, here we go. That are the 2 in the front of the x. I'll put a parenthesis like that. So this does not equal 1. So let me rewrite it. Limit as x approaches 0. And if you have colored pencils, this is perfect for colored pencils. Over x. So everything in red is original. Or if you have a pen and a pencil. What do I need to add in the bottom for me to be able to use this property? A 2. But this is not magic. I can't just magically add a 2. So I got to balance it. So here it is. In blue is what I'm adding. I put a 2 in the bottom. If I put a 2 in the bottom, I got to balance it like in chemistry. What do I got to do to the top? Put a 2. So there it is. I put my 2 there in the top to balance. Do you guys see what I did? Okay, so now this that I'm circling, sine 2x over 2x, that is that property. That is this. So what you have here is, let me write it over here, is 2 times 1. Do you guys see that? What's my answer? 2. Do you guys see how we got the answer of 2? Okay. We're all good. Don't worry, we're going to do more of this. We're going to do more. Let's see, what's our next letter? Letter E. All right. From your algebra days, I know it's been a while for some of you. X cubed minus 125. That 125 should be a big hint. Look at that 5. 125 is the same thing as 5 times 5 times 5. So the numerator is the difference of cubes. I'm going to write the formula down for you guys. So the difference of cubes, write this down. Diff of cubes. So if you have a cubed minus b cubed, that is, let's see, do I have enough space? Yeah, I do. A minus b, parenthesis, a squared plus ab plus b squared. That's what the difference of cubes is. And I'll write the other one. If that's the difference of cubes, what's the other formula called? Sum of cubes. I guess you can't read my mind, but sum of cubes. A cubed plus b cubed. That's an a. It just looks like a 9 there. That one's going to be a plus b a squared minus ab plus b squared. It's really easy to memorize, or how easy is it to memorize? See how that's a minus? So it starts with a minus, everything's plus. See how that's a plus? It starts with a plus, put a minus in the middle, the other one's plus. If you were to distribute this, and I can show you, because I know maybe Galan probably wants to see it. If you were to multiply this by this, you will get the a cubed plus b cubed. Do you want to see it, Galan? No, okay. All right, let's do one. I'm not going to do both. Let's do one of them. So you choose. Do you want me to do the difference of cubes or the sum of cubes? The difference? Okay. Look, I'm just going to I'm going to erase this, but just observe. Just look. What's a times a squared? A cubed. What's a times ab? A squared b. And then what's a times b squared? AB squared. That's it. You're done with that. Now I'm going to go to the b. So negative b times a squared. Yeah. Negative b times positive ab. Negative b times positive b squared. B cubed. Look what happens right here. I have a positive a squared b. I have a negative a squared b. What happens? Cancel. I have a positive ab squared. I have a negative ab squared. What happens there? Oh, look what you have left. A cubed minus b cubed. Cool, right? Okay. How do we feel, guys? There is also something called Pascal's triangle. Yeah, let's not talk about it because then we're going to go off of a tangent and do that all. But these are all related. Google Pascal's triangle later on, and you can see how they're related. If you're in decathlon, hopefully you remember our lesson from last year, but no big deal. You can use Pascal's triangle to create. I'll stop talking. Let's just do this. All right, here we go. Yeah, this is all algebra. Hopefully you guys are remembering that. All right. Did I erase the formulas? I didn't want to erase the formulas. Okay, here we go. Limit as x approaches 5, and there's a difference of cubes, so I'm going to write x minus 5 close open, x squared plus 5x plus 25. Does everyone know where that came from? It came from the difference of cubes, all over x minus 5. What is going to cancel? The x minus 5. Bam, bam. Now can I do direct substitution? Yes. Notice I'm just going to write equals, and I'm just going to plug it in right away. 5 squared is 25. 5 times 5 is 25, and then plus 25. So all three of those added together is 75. How are we feeling, guys?
Oh, wait, sorry.
Yeah, hit me.
So, like, could you kind of do, like, sorry. Okay, wait, so the x minus 5 is, like, wait, sorry, could you just write x minus 5, like, x minus 5 3 times, and then, like, cancel it once, and then, like...
No, this is not x minus 5 to the power 3.
Okay.
This is the difference of cubes. If it would have been x minus 5 raised to the power 3, then yeah, 3 times. But that's not x minus 5. This is the difference of cubes. You're thinking of x minus 5 to the third power. That one you use that stuff, right? Are you guys okay? Oh yeah, sorry, I didn't see you there.
Is there sum of squares?
No.
Like a difference of squares?
No. You guys okay? Yeah, here we go. Letter F. Don't worry, guys, we're going to go slow. You see sign X. Immediately your brain should go to limit as X approaches 0 of sine happy face X over happy face X equals 1. We don't have to worry about that. I guess we can just erase the happy face because this doesn't have any coefficient in front of that X. You still okay? Here we go. Limit as X approaches 0. You're going to leave the numerator alone. The denominator, what am I going to factor out? Not a 2, just an x, and you're going to have 2x minus 1. Do you guys see that? Now I'm going to expand it. Limit as x approaches 0. Here's my little bracket because I'm going to expand it. Sine x over x times 1 over 2x minus 1. Are we okay? If you multiply, everything's okay, guys. This is a dot, so it's a product. So that's x times 2x minus 1. I still have that. Do you see that? All right, here we go. Now I can do direct substitution. Sine x over x as x approaches 0, that's just going to be 1. So I have 1 times, and then do direct substitution here. 2 times 0 is 0. 0 minus 1 is negative 1, right? So what's 1 divided by negative 1? Negative 1. What's 1 times negative 1? So this is just negative 1. Or I guess if you wanted to rewrite it, limit as x approaches 0 of sine x over 2x squared minus x is just negative 1. We're okay?
Hey, wait, can you say that again?
Oh. Yeah, how do I get negative 1? Limit as x approaches 0 of sine x over x, that is 1. And then look, I can do direct substitution with this. 2 times 0 is 0, minus 1 is negative 1. So, or you can 1 divided by negative 1 is negative 1.
X minus 5. And then if we put it like this, that's x, right? A is x, right? So then 9x.
All right.
And then 25.
When I give you guys a test on limits, I will make this question a bonus, but you have this question again on UH. And guys, I know AI can do all these questions. I already talked. Dr. Morgan had a presentation in Houston. He was the dean. He just retired about 2 years ago, and he said it himself. He said AI can do 100% of all the questions on UH. I don't want to know what AI knows. I want to know what you know. Don't use. I mean, yeah, you use AI to help, but don't use AI just to get it out of the way, guys, because it's only going to hurt you. It's going to be obvious. If you're getting hundreds on all your online quizzes, and then I give you an exam, and I just literally just cut and paste those questions onto an exam, and you don't perform like you performed online, I'm gonna be like, oh, she just went through the motions. She just used AI. So don't let it happen to you guys. I'm not gonna mention the class. Okay. All right, you guys ready? All right. So this one is quote unquote tough. It requires a lot of your pre-calc knowledge. I see 1 minus secant squared of 4x. The only thing you guys know right now is the limit as x approaches 0 for sine happy face x over happy face x is 1. That one, and then you know the other one. 1 minus cosine x over x is 0. But since it equals 0, it's not really all that good, at least right now. But it will come out later on. All right, so here's what we're gonna do. You guys ready? No, don't worry. I need your full attention, guys. So here we go. Start with what we know. We know Pythagorean theorem. We know that cosine squared theta plus sine squared theta equals 1. You guys know that, right? All right, next, I have 1 minus secant squared. I know that I can get secant squared if I divide all these by cosine squared. 1 over cosine is secant. So I'm going to go divide by cosine squared, divide by cosine squared, divide by cosine squared. That's what we did last time when we were in pre-calc to derive them. Cosine squared divided by cosine squared, that is 1. Sine squared divided by cosine squared, that is tan. And 1 over cosine squared, that is secant squared. I see a tan. That's good news for me. I'm going to move the secant squared to the left. I'm going to move the tan squared to the right. So 1 minus secant squared theta equals, that's an equals, it just came out like, equals negative tan squared theta. Are we still okay? Okay, so it doesn't look like I'm going to use this one, but I am going to use this limit. So let me write the property. Limit as x approaches 0, and I'm going to use this one. Tan of happy face x over happy face x equals, what does that equal? 1. It equals 1, guys. How do I move this? Okay, I'll figure it out later. Are we still okay? All right, that's what I want. So here we go. I'm going to come back, and I'm going to replace a 1 minus secant squared with negative tan squared. Now, I got to keep the argument, so I'm going to write limit as x approaches 0, and instead of writing 1 minus secant squared, I'm going to write negative tan squared of what argument? 4x. All over, and I'm going to go ahead and square the 6x. So I'm going to write this as 36x squared. So catch up to here. Are we still okay? All right, next. What's my next move? I'm going to write limit as x approaches 0, bracket, because I'm going to expand it. I'm going to put the negative here, and then I'm going to write tan of 4x over one of those x's, that says x squared, times tan of 4x over one of those x's times 1 over 36, and I'm going to close it. So that right there is the original. And if you have colored pencils, go ahead. This is the same as this line up here. Tan times tan is tan squared. Are we still okay? Nothing crazy, right? Okay, take a colored pencil or something that you can differentiate between whatever you're using. What do I need for this one right here, that tan 4x? What do I need for that to be a 1? I need a 4 where? In the denominator. So I'm going to put a 4 there. So there's my 4. Whatever you do to the bottom, you got to do to the top. It doesn't matter where you put it. I'm going to put it way over here on the right-hand side. Because it's just easier. It makes life easier. What about this middle term, tan 4x? What do I need in that denominator there? Another 4. So I'm going to put a 4 there. If I put a 4 down there in the denominator, what do I need in the top? Another 4. I think we're ready. Here we go. Equals. So let's see. I have a negative there. You see that negative? That negative, I'm going to bring it right here. So negative. And then tan 4x over 4x, that is just 1. So there's my negative 1. Times, what's tan 4x over 4x again? 1 times, and I guess it depends on how you see it. If you want to write 16 over 36, you can. I kind of want to take that 4 and it goes into 36 9 times, but okay. You guys probably like the 16 over 36. Okay, so I'll leave it. What's 4 times 4? 16 over 36. Are we still okay? All right, so I see this as negative 16 over 36. And I like to just divide everything by 2 if everything's even. 2 goes into 16. Is that 8 times? 8. 2 goes into 36. What's that? 18 times? 19 times? No. 30. What's half of 36? 18, right? Yeah, 18. I don't know why that gave me such a hard time. I still see that they're even, so I'm just going to keep reducing it by 2. Negative 4 over 9. Oh, look, it doesn't reduce anymore. So negative 4 ninths. How do we feel? Do we feel okay? All right, I know, guys, we did a lot. So here's what we got lined up. I didn't print out handout activity 2 because I feel that the more I give you, the more that you might feel overwhelmed, like on you. So I'm going to, if you want it now, let me know. I didn't print it out. Come by after school and I'll give you the handout already. But I think right now we need to practice with Delta Math. Now the UH Limits 1 is a done deal, so I'm picking that up this Sunday. If you want to start on Limits 2, I think you can. We're just got to do one more notes for that. DM number 3, start today. I have the due date of that for tomorrow. UH Limits 1, attempt no later than today. I think all of you have already attempted. Maybe one of you hasn't. And then the final grade, I'm going to pick it up this Sunday. And there it is, guys. How do we feel? Do we feel okay? All right, we're done, guys. So take care of business, and we'll call it a day. Say it again? Yes. Oh, tomorrow we're going to be outside, by the way.